This is CCC. I'm studying in Sri Venkateswara College of Engineering, Bangalore. My USN is 1B 23CS157. I'm from C section. Topic utilization of K-map in exploring cause-effect relationships modeled by partially defined Boolean functions. Utilization of K-map in exploring cause-effect relation modeled by partially defining the Boolean functions. This paper explores cause-effect relationships by modeled by partially defined Boolean functions using a modern regular and modern age variable K-map. The author present a K-map test to determine whether a variable is essential for functions and introduced a method for excluding variables from the set of supporting variables. The paper aims to address a dominantly unspecified PDBF to obtain all its minimal sets of supporting variables without resorting to integer programming techniques. A running example, a exclamatory number of considerable faculties, the conversion of two table in table 1 to K-map in figure 1. The configuration is simply located at the horizontal coordinates and the vertical coordinates. Note that the map input is given in terms of the shown designations of the y and z variables or equivalently by the corresponding values of and which are deduced from the equations 1 and 2. A few remarks about this running example are ordered. The problem of cause-effect of relationships. The paper focuses on the problems of identifying the minimal subsets of plausible cause of the given effect among a large set of factors, including all the potential causes. Along with many other factors, this problem is particularly relevant in fields like artificial intelligence, machine learning, and qualitative and comparative analysis. Limited observation. The author emphasizes that when only partial observations are available, no methods can provide defined answers. However, they believe that even then the cause-effect relationships can be narrowed down specifically to provide subsequent guidance. NP hard problems. The uh, complication problem arising in the framework such as driven minimal sets of supporting variables of finding all irredundant sums for each of these sets are NP hard. However, in the most applications of interest, the number of explanatory factors and observations are expected to be reasonably small. QCA and digital circuit design. The problem addressing in the paper is similar to those addressing by QCA, but it has suitable differences with the problem of digital circuit design. Construction and use of the K-map. The construction of the K-map is based on repeated applications of Boolean expansion. This expansion expresses a Boolean function in terms of two substances which are obtained by restricting the functions to O and 0 and 1 respectively. The paper discusses how the K map can be split into two halves representing the internal and external domains of variable. The authors explain the variable can be excluded from a set supporting variable if certain conditions are met, including the absence of contradictory mirror image cells and appreciate the assignments to don't care cells. Boolean Sharingan expansion. The construction of K-map is based on the represented applications of Boolean expansion, which expresses a Boolean function in terms of its two subfunctions. Map folding. Various types of map folding allow the replacement of a n variable map by two variable maps. Variable exclusion. A variable can be excluded from a set of supporting variables if certain conditions are met, including the absence of contradictory mirror image cells and appropriate assignments to don't care cells. The paper presents a regular and modular eight-variable K-map to solve the running example. The author demonstrates how the map can be used to identify minimal sets of supporting variables by systematically manipulating the don't care cells to make the outcome functions independent of a certain variable. This process leads to discovery of several minimal sets of supporting variables, each within its own set of iridium disjunctive form. The paper highlights the implications of the approach of QCA. The authors argue that the two often stronger results claimed by the OCA and other hands need to be checked and circumcised. They suggest the more objective are needed to narrow down the possibilities and decrease the number of candidates IDFs. The author emphasizes that the given performance to certain IDF over others should be context specific rather than tool specific. The K-map is a powerful tool. A paper demonstrates the power of K-map as tool of exploring cause-effect relationships in a particularly defined Boolean function. The author shows how the map can be used to systematically identify minimal sets of supporting variable and construct all the irradiance disjunctive forms (IDFs). This approach offers a valuable alternative in integer programming techniques and provides a more irritative and visual understanding often of the problem. The paper emphasizes the importance of a rigorous method in analyzing the cause-effect relationships. The authors argue that too often strong results claimed by the QCA, other hands, need to be checked and circumstanced. They suggest that more observations are needed to narrow down the possibilities and decrease the number of candidates IDFs. This highlights the need of careful interpretation of the result and importance of the considering manipulation. The future of cause-effect analysis. The paper suggests the K-map approaching offers a valuable contribution to fields of cause-effect analysis. The authors believe that this method can provide a more rigorous and narcissized understanding of complex relationships, particularly in the areas like QCA. They encourage further research and development of the approach to enhance its capabilities and burden its appliances. Conclusion: the paper concludes by emphasizing the importance of using the rigorous methodology and considering multiple perspectives when analyzing cause-effect relationships. The author believes that the K-map approach offers a valuable tool for the purpose of encouraging further research and development to enhance its capability. Thank you for watching my video.